Have you ever wondered how the internet knows where to send your data? Today, we dive deeper into the world of Border Gateway Protocol to discover the answer. To understand the internet's vast and complex architecture, we must first understand the Border Gateway Protocol, or BGP. This key protocol is the postal service of the internet, routing your data to its correct destination. But BGP is not just a simple mailman. Its advanced concepts like route reflectors, confederations, and BGP peering make it an intricate and fascinating system. Route reflectors help to spread information within a network, while confederations work to simplify the internal structure of the network. And BGP peering? That's the agreement between networks to reciprocally provide access to each other's data. Intrigued yet? So buckle up as we journey into the intricate world of BGP and its advanced concepts. Imagine being a postman with thousands of addresses to remember. Pretty tough, right? This is where route reflectors come in handy in the world of BGP. In the Border Gateway Protocol, or BGP, we deal with complex networks, and managing routing information can be a daunting task. Route reflectors are like our postman's address book. They are a solution within BGP that simplifies the management of routing information. A route reflector is a router that forwards updates to IBGP peers. It's a way to bypass the standard rule that IBGP speakers only exchange routing information with their peers. This rule can lead to a full mesh topology, where each router needs to connect with every other router. For a large network, this becomes complex and inefficient. With route reflectors, we can streamline this process. Instead of having each router connect with every other router, they connect to a route reflector. The route reflector then shares the routing information with the other routers. This simplifies the topology and reduces the number of connections needed. Think of it more like a postman delivering mail in a large city. If he had to remember every single address, it would be overwhelming. But if he has a central post office, or in our case, a route reflector, where he can pick up his deliveries for the day and the best route to take, his job becomes much simpler and more efficient. Route reflectors don't alter the routing information they receive. They merely reflect it, hence the name. This ensures that the routing information remains accurate and consistent across the network. So, in essence, route reflectors are like a central hub, a beacon in the complex world of BGP, reducing complexity, improving efficiency, and ensuring consistency. They are a critical tool in managing and simplifying the routing process in BGP. So just like our postman, BGP uses route reflectors to effectively manage and simplify routing information. Now let's talk about confederations. No, not the political entity, but a crucial component in BGP. Confederations, in the world of Border Gateway Protocol, play a significant role in managing large networks. Imagine you're tasked with organizing a colossal international conference. You wouldn't want to coordinate with every single participant directly, would you? Instead, you'd group them into teams, delegations, or, for our purpose, confederations. In a similar fashion, BGP confederations help manage numerous connections efficiently. When a network grows large, it becomes increasingly tricky to maintain full mesh peering. This is where confederations step in, like the efficient conference organizer we mentioned earlier. Confederations break up an autonomous system into smaller, more manageable autonomous systems known as sub-AS. These sub-AS are then interconnected, creating a structure that significantly reduces the number of connections required. This is akin to how you'd break down the mammoth task of managing a conference into smaller, more manageable tasks. Now you might ask, how do these confederations work within BGP? Well, it's like this. Confederations use BGP to communicate with other networks, and Interior Gateway Protocol, or IGP, to communicate within the network. This allows for a smooth flow of information, ensuring everyone in our metaphorical conference knows where they need to be and what they need to do. So why are confederations important? They bring efficiency to the table. By breaking down a large network into smaller sub-AS, confederations reduce the complexity of the network. This, in turn, makes it easier to manage and maintain the network, much like how breaking down the conference into smaller tasks makes it easier to manage. The importance of confederations cannot be overstated. They are the silent heroes working behind the scenes, ensuring that the network runs smoothly and efficiently, just like our conference organizer, ensuring that everything goes off without a hitch. So, confederations in BGP help manage a large number of connections efficiently, much like a well-organized conference. Next on the list is BGP Peering. Think of it as the handshake of the internet world. BGP peering is the process of establishing a connection between two networks, known as autonomous systems, on the internet. It's like setting up a conversation between two people. Only in this case, we're talking about massive networks. So how does BGP peering work? You wonder? Well, let's break it down. When two networks decide they want to share information, they establish a BGP session. This is a direct, dedicated link between the two networks through which they can exchange routing information. This exchange is what we call BGP peering. Now, you might be asking, why is this important? Why do networks need to share information? The answer lies in how the internet functions. The internet is a vast network of networks, and for data to travel from one end to the other, it needs to know the best path to take. This is where BGP peering comes into play. By sharing routing information, networks can guide data along the most efficient route, ensuring it reaches its destination quickly and accurately. But it's not just about speed. BGP peering also plays a crucial role in the stability of the internet. If a network were to suddenly go offline, the shared routing information would allow data to be rerouted through another network, preventing a total collapse of the system. And there's more. BGP peering also allows for greater control over internet traffic. Networks can choose which routes to advertise and which to keep private, enabling them to manage their traffic more effectively. This is particularly important for large networks, where managing traffic can be a complex task. In essence, BGP peering is a fundamental part of how the internet operates. It's the handshake that ensures smooth communication between networks, directing traffic and maintaining stability. Without it, the internet as we know it would simply not function. Hence, BGP peering is the essential handshake that ensures smooth communication over the internet. With all these concepts, you might be wondering, how does it all come together? Well, let's delve into that mystery. You see, these advanced border gateway protocol or BGP concepts don't work in isolation. They're like the pieces of a jigsaw puzzle, each fitting perfectly to create a beautiful, coherent picture. That picture is the seamless and efficient operation of the internet. For instance, consider a multinational company with offices spread across the globe. Each of these offices needs to communicate with each other, right? That's where our advanced BGP concepts come into play. Firstly, we have route reflectors. Instead of having to maintain a full mesh of IBGP peers within an autonomous system, they simplify the network by reflecting routes to other routers. This way, each office doesn't need to communicate with every other office directly. Instead, they communicate with the route reflector, which then sends the information to the necessary office. This not only makes the network more manageable, but also reduces the overall system complexity. Then we have confederations. They are used to control the propagation of routes within a large autonomous system. In our example, this could be used to manage the flow of information between different regions where the offices are located. By dividing the large autonomous system into smaller, more manageable ones, confederations ensure that the network remains efficient and scalable. Lastly, we have BGP peering. This concept establishes a direct connection between two networks, allowing them to exchange routing information. In the context of our multinational company, BGP peering could be used to establish a direct connection between two offices, facilitating a more efficient exchange of data. So, you see, each of these advanced BGP concepts plays a crucial role in ensuring that the global network architecture remains efficient, scalable, and manageable. They're like the gears in a well-oiled machine, each turning smoothly to keep the whole system running. So by working together, these advanced BGP concepts ensure the internet is a well-oiled machine. In just 10 minutes, we've journeyed through the advanced concepts of BGP. Impressive, isn't it? We've navigated the intricate world of route reflectors, an essential part of BGP that reduces the number of connections needed in a network. We've explored Confederations, a smart solution to manage large networks, making them more scalable and easier to handle. And let's not forget our deep dive into BGP Peering, a practice that facilitates the exchange of routing information between networks. These are not just abstract concepts, but vital components in the grand scheme of the internet. They ensure that data is routed efficiently and accurately, making our digital world possible. Understanding these components is a stepping stone towards mastering the art of network engineering. Remember, every time you browse the internet, there's a complex system working tirelessly behind the scenes. And now you know a little bit more about how it works. Until next time, keep exploring,